So what we have learned on the previous lecture was we learned what is electricity, right? What is electricity, what is current, how to calculate them, those things we learned, right? What are the circuits available? So here, and also we learned the basic electronics components, right? So today also we are going to learn some electronic components, right? Let's see what are the electronic components and how they will work, right? Now we are going to see circuit boards, right? There are several kinds of circuit boards available in robotics, right? We can buy several kinds of circuit boards. Circuit boards means the boards are used to connect some electronic components, right? We are going to connect two components together by using the breadboards, right? But we can use these circuit boards. For an example, a circuit board is called breadboard, right? Breadboard means uh, I can show you. This is the breadboard, right? I can show you. This is the breadboard, right? This is how it will look like. So on the back side, I have removed uh, this sticker so that you can see the inner parts of the breadboard. This is how a breadboard will look like, right? So in the top part, the lines are connected like here, right? So there is a straight line going in this horizontally, right? So horizontally there is a line, and also in this breadboard, in these lines, the middle lines, right? So the middle lines are connected like this. So you can see that. So this line is connected here, and these vertical lines are connected, but not this area and this area is connected, right? So these two areas are separated, and only these lines are connected. So hope you can see also on the presentation. In the presentation, you can see that these horizontal lines are connected like this, right? Also on the bottom area, bottom layer is also connected like this, right? So then after, the vertical lines are connected like this. So this is how a breadboard will look like. Yeah. So this is how a breadboard will look like, right? So if you connect two wires, which means you can use wires, right? So here I can see, I can show you. This is called a jumper wire, right? So this is jumper wire. We'll learn also in the next slide also. This is called a jumper wire. This jumper wire is particularly used to connect these breadboards, right? If it is a normal connection, which means if we are going to connect two components, as an example, we are going to connect a battery and the bulb, we can connect by using normal wires, right? Normal these kinds of wires we can use. But if we are going to connect with the breadboard, we have to use some special wires, right? Special wires means this called as a jumper wire. So we have to use this jumper wire because this jumper wire has a line here, right? So has a metal line here. So this line is connected to the breadboard like this. Here, this way we can connect, right? So if I connect a wire like this and this other end, right? So this other end can be connected to somewhere else. So okay, now we are learning circuit boards, right? So this is the beginning of the class. We are learning circuit boards, right? You can also ask, you can also unmute yourself, right? I have added you as a, you can also unmute yourself So if you have any clarifications, you can also unmute yourself and then ask, right? So that we are learning is circuit boards. Circuit boards means circuit boards are used to connect two electrical components, so electronic components. So in order to connect two components, as an example, if you are going to connect a battery and a bulb, we use these circuit boards, right? So basically, uh, one of the circuit board is breadboard, right? So this is how a breadboard will look like. So that is we are learning. In breadboard, these lines are connected. These horizontal lines are connected truly, right? Then these vertical lines are connected. These lines are connected. These are connected. So these things are connected. But this area and this area is not connected, right? So that is you can see on the slide also. These two lines are connected similarly, like as I shown here. So why we use breadboards? You know that we are using breadboards to connect two components, right? So in the top area, which means the top side, we are going to use the breadboard for connecting the batteries, right? So as an example, if we are going to use a battery, so let's say this is a battery. It has a positive terminal and a negative terminal, right? So in positive terminal, we have to connect a positive terminal to the breadboard like this, right? So in the whole horizontal line, in this line is connected to the battery. So which means this whole line is 5 volt. If we connected if we connect this line to a 5 volt battery, the whole entire horizontal line is 5 voltage, right? And also we connect the negative terminal to the breadboards on the most top horizontal line. So that way we are grounded this line. So we grounded this top line, right? So after what we do is we are going to connect the bulbs, right? So how we can connect the bulb is very simple, right? If you take an LED bulb, it will look like this. We learned this in our first class, right? So this is an LED bulb. If the line is very bigger, it is called a positive terminal of the bulb, right? We know that. If the small shorter line is the shorter line is negative terminal, right? So we have to connect the bulb in the breadboard. So directly we can connect. So if we connect the bulb like this way, so you can see, just a second. So this is a breadboard, right? So here we have a battery, positive terminal and a negative terminal. We connect this positive terminal to this pin, right? So we take a negative terminal and connect this one to this pin, right? So then after we have a LED bulb like here, and we how can we connect? So if we connect this line and this line, this is wrong. Why this is wrong? Because these two lines are connected together, right? So you know that because this is the line. So these lines are connected together. So we can't connect like this. So how can we connect this? Very simple, right? So we have to connect, get a line here, and then we have to connect from this pin to this pin. Negative terminal can be connected to this pin, so that this is a separate wire, which means this is a separate line, this is also a separate line, right? So then after, what we do is we can power up this light, right? We can power up this light by obtaining positive charge to positive terminal. Positive is to be connected to positive, negative is to be connected to negative, right? So hope you know that. So then what we do is we take a wire, we take another jumper wire like this. We obtain another jumper wire, and then we connect this line and to this line, so that this is a line, so these are connected, so if we connect this pin, it is also connected as this pin. So we obtain a wire and connect this one to this one. So then after, what we do is we connect this line. I will use it another color. So we obtain another color wire, and then we connect this one to this pin. Whatever the horizontal line, we can take it. So if we connect it like this, the bulb will be turned on. So this is how we connect, and this is how we interact with the circuit boards, right? These are very simple things, right? First, if we see the breadboards, firstly it will look confusing, right? So that is why I have removed the sticker and I showed it to you. So this is how the lines are connected, right? So these are the vertical line, these are vertical, this and this are not connected, right? So these are separate things. This is a separate area. This is a separate area, but these lines are connected together, right? But in this is also another separate area, right? This horizontal whole entire line is connected, right? Hope you understand this. If you don't understand this, please ask it to me, so I will clarify it to you another time. So hope you understand this. I have also some of the exercises for you to practice these things, right? So if you buy an Arduino starter kit, and it has some of the components, right? So then you can connect and play around with these things, right? So the next thing is, this is a temporary mounting. So why we use this breadboard is for practicing, right? So this is a temporary mounting equipment. So but what I have boxed here, these are permanent mountings, right? Permanent mounting means if we have to connect two components, we have to solder them, right? Solder means we know that we have to both them, right? So both the components, right? This is how a dot board look like, right? If you obtain a dot board, and it will look like this. In a dot board, it is, as the name indicates, that dot board, each and every dots are not connected together. Each and every dots are separated, right? There is no any connections between the dots. So what we have to do is, if we want to connect two wires, as an example, if we want to connect this is a battery, say an example, this is a battery, right? So we have a positive terminal, a negative terminal. A negative terminal can be connected somewhere else, right? So these dots are not connected together. So if we want to connect them, we have to manually connect them by soldering these things, right? Soldering means we have to obtain we know that the soldering iron. So then we have to solder them together. So then we can also connect the LED bulb here. So we have to connect LED bulb in one point, and we have to take another point, and then if we want to connect them, we have to manually solder by using the soldering iron. So we have to manually solder this one, and we have to manually solder this one. So in it's we have to manually solder this way, right? So in engineering, if we take further step, in engineering we don't connect like this, because this is ugly, right? So in engineering we don't connect like this, right? What we do is, we only take one portion of the board, right? We don't waste the entire board, right? So what we do is, we take only one portion of the board, right? So then what we do is, we connect nearly, right? We connect the positive terminal here and the negative terminal here, right? Then after, what we do is, we connect the LED bulb's positive terminal here and the negative terminal here, so that we can easily solder them by using a lesser amount of material. So and then easily we can also solder them together. So that is how we use. So on the other space, so in this dot board, we have a lot of more other spaces, right? So on the other spaces, we can use them for another projects. right? So we can connect several LED bulbs, and we can connect motors, etc. So that is an engineering practice. We have to only utilize the board for only a one area, right? If then after we extend this area for another projects, right? So hope you understand this also. And this is how a dot board works, right? And the next thing is line board, right? Line board means, so as you can see that this is a plastic material, right? So this is basically this is a plastic, and these are copper dots, right? So these copper dots uh, uh, can be good conductors. So then it will conduct the electricity for us. So the next thing is line board. Line board means, as on the breadboards, the top area is connected similarly. The top area is connected horizontally, right? So similarly, in the line board, these lines are connected, right? So these entire lines are connected together, but these two lines are not connected here. So that is the case we have to understand, right? So this is how a breadboard connected inside. This is the middle area is connected like this, right? Also in the line board, this is how the line board is connected, right? So hope you understand these things, right? So then after we are going to learn printed circuit boards, right? Printed circuit boards means what we do is we obtain these are some advanced things, right? This is how we are going to manufacture the real components. So these things are available for us to practice with the electric and electronic components, right? So these things are very advanced, and what we do is we design these printed circuit boards, right? The PCB, in short term, we call it as a PCB. What we do is we manually program, right? So we manually arrange the circuit components, such as we obtain in computer, we obtain a board like this, and then we add resistors and the batteries and the spaces for the bulbs to be connected. So then we design each and every part, right? So each and every component we design on computer. So after we have designed these things, and then we print these things, we manufacture these boards, right? There are uh, online printing services available for us to get the printed versions of the PCB boards, right? So we don't have to manually manufacture. There are online services available, maybe outside Sri Lanka. Then they will print us the design for us. Then we can obtain that shipment. Then after we can connect the each and every components as per predetermined spaces, right? So that is very easy. These things will be discussed in the advanced robotics, because these are very complicated things, not for basic O-level students. This can, but also uh, it will be very much interesting in if we are manufacturing the components for longer periods, right? If you are going to manufacture a real device which can be used for up to 10 or 20 years, we have to definitely go for printed circuit boards, right? Then only you can give the warranty to your customers, right? So those are the separate things, not in here. So hope you understand the circuit boards, right? So if you don't understand any of the things, you can ask it to me. I'm friendly. I'm very friendly to the students. If you have any questions or to clarify, you can clarify it to me. So then only I can understand how much have you understood about the questions, the subject, right? So ask questions. So next thing we are going to learn is types of wires, right? And jumper wires, I showed that jumper wires look like this one. So in jumper wires there are three type of categories, right? Three type of categories. One category is male to male jumper wires, right? Male to male means on the, if you zoom it, and on the one side is it has a pin, right? It has a pin. We call it jumper pin, right? On the another side it also has another pin, right? So if both the ends have pins, it is called as male to male jumper wires, right? On the other hand, if the both ends are having holes in the ends, it is called as female to female cables, right? As similar to that one, if the one hole, the one end is having hole and the one end is having the pin, it is called as female to male cables, right? So hope you see that why we use these kinds of cables is very easy, right? To understand it, it is very easy, right? Because as you can see on the video, as you can see on this video, I have a relay, right? Here I have a relay. If you look this relay, uh, here the relay has the pins, right? You can see that these are pins, right? So it, what we call is male pins, right? So in order to connect this relay and this breadboard, we have, what do we have, what we have to have, what the wire, what type of wire do we have? Because this is a male pin, right? So in order to connect this male pin, we have to have a female pin, right? So we have to have a female jumper cable, right? Female jumper cable we have to have. Then after we connect this female cable here, we have to connect another end to the breadboard, right? So in order to connect this breadboard, we have to have a male ended pin, right? So we have to have female to male jumper cable in order to connect these two components. So those things, I think that you understand these things, why we use these kinds of different kinds of cables, right? So hope you understand these things. So then after, we will also use these auto wires, right? So why we use auto wires? Auto wire is similar, will look like this, right? This is called auto wires. So auto wires we use for the purpose of higher amount of current to be conducted through the cable, right? Because if you look at this cable, these cables are rated, right? Because these cables diameters are very smaller. Even the diameters will be 1.2 millimeters, or within within very small, like within 2 millimeters. 2 millimeters mean very small, right? Tiny amount. If you look at your components inside your Arduino box, inside your Arduino kit box, you can see these types of wires, right? So these are very simple, and these are rated for only conduct small currents and small voltages, right? So what we have here, these are auto wires. These wires are readily available for us to purchase in order to connect the AC components. AC components means, I in yesterday class I told that we can connect even AC wires, right? So we can connect a bulb, AC bulb here, right? AC bulb here, but we can't connect an AC bulb in by using the jumper wire, because if we allow the current to flow through, allow the higher current, right? Higher current means in our home appliance current. If we connect the home appliance current to this jumper cable, the jumper cable will be uh, fired up, right? So hope you understand the word fired up. So that is why we use these kinds of cables. If the current is high, the current and the voltage is high, more than 24 voltage, we more than even I prefer to use 12 voltage connections to this wire, right? I prefer to use 12 voltage connection to this wire, 12 voltage, even 2 amperes or 3 ampere current. I prefer to use these kinds of wires. So that is how we can ensure that the connection is safe, right? So these wires can also be purchased from the shop nearby you. So I have a relay here. So yesterday I explained this relay, how it works. So it has 3 pins here. So 3 pins for jumper cables to be connected, right? So uh, jumper cables, the relay has rated here. If you look at this relay, I will show the picture also. I will upload the picture of the rating in our WhatsApp group also. So don't worry about if it is not seeing, it is not see clearly. uh, in the relay, it shows that it has 5 voltage DC and 240 voltage AC current, right? So in this side of the relay, we can connect the small voltages and the small currents, right? 5 voltage, 12 voltage, those kinds of voltages can be connected here. On the other side, because it has a bigger holes to connect here, we can connect 240 voltage on the other side, right? So hope this circuit is separated and this circuit is separated. If we connect these circuits together, it will be blown up, right? So hope you know that. So that is the reason I told you, don't work on the 240 voltage AC current, right? In your home appliance, don't work on your home current, right? So only work what is inside the box, right? In your Arduino box, if you obtain your Arduino box, it will have the small components in small battery, 9 voltage. The current is very low, right? So you can work on that, right? So you can work on your Arduino kit. uh, don't fear about, don't afraid to work on the small current, right? Small current means 5 voltage, 12 voltages, you can work on it, right? But on higher voltages, don't work on that. Okay, so hope you understand those things. You can fearlessly work on what is inside your Arduino box, and you can connect the components. But before you connect Arduino pins and your computers, don't connect, right? Because after my lectures are finished, then after you can connect. Because if you connect an Arduino, so let's say this is an Arduino, right? This is called as Arduino. You have to connect an Arduino for your computer to program this device, right? So that is also very easy. But while you have connected uh, this Arduino to your computer, you don't have to uh, insert the battery in this jack, right? If you do these two things at the same time, the Arduino will be broken, right? So that is the case we have to consider. So don't work on these devices until I ask you to do, right? So next thing we are going to learn is measuring electrical properties, right? So we saw what are the electrical properties, current, voltage, resistance. How can we measure those things? It's very simple, right? So for the purpose of measuring the electrical properties, we have a device that is called multimeter, right? So this is how a multimeter will look like, right? So hope I can show it to you also. So this is the multimeter, right? So multimeter means, as the name indicates, that we can measure multiple properties, right? Multiple properties means we can measure uh, electricity, which means current. We can measure voltage. We can measure resistance, and also we can measure this, which is called a continuity test, right? I will come to that later. What is the meaning of continuity test? I will come to it later, right? So first of all, I will explain this component. This is a multimeter. So There are several kinds of multimeters available in the market. So this one is for rated. This one is rated for uh, 10 ampere DC current, right? So this one is rated for 10 ampere DC current. So up to 10 ampere current I can measure from this device, right? So further, if it is a 13 ampere current, I can't measure by using this device. So according to the current that we can measure, the device can be vary, and the device's prices also can be vary, right? So this is very simple, right? This tool, this simple tool will help you throughout your life, right? So throughout your life you can check multiple things, right? Because engineering is very interesting thing, right? So if you uh, go further in science and mathematics rather than only studying the theory, if you apply the applications, if you learn the applications of science and engineering even in the mathematics, it will be very interesting, right? So we calculate the Ohm's law and we calculate the theory parts. That will be boring, right? So if we are interested in doing these kinds of applicable things, that will be very much interesting for us to pursue our career. So that is called engineering, right? Engineering, and there is a difference between a scientist and an engineer, right? A scientist will only work on the theories, right? He only write theories and formulas, all the things, right? So what engineers do is different, right? Engineers collaborate with the theories, and then they create innovative products, right? They create new products. There is also a misconception among the people, engineer and the mechanic, right? So a mechanic means, that is a different thing, right? If you don't study, you will become a mechanic, right? So that means mechanic can repair this device, right? So as a mechanic, he can repair this device. He can repair fan, he can repair laptop, he can repair whatever the thing that is exists on the world, right? So but what engineers do is different, right? Because engineers will make these components, right? If there is a problem, an engineer will find a solution for that problem, and he will make a new product like this, not even similar to this one. So that is the purpose we are studying, right? If we don't study, we will become mechanics, right? We can become mechanics very easily, right? If we go a technical college and obtain a course, that will be very much easy for us. Within 6 months you can become a mechanic, right? So but if you want to become engineers, you have to study more, you have to put an effort on studies, right? So that is very important. You have to put an effort on theoretical things, you have to put an effort on applicable things. uh, you have to study more science and mathematics, right? Also you have to study English also. So if you don't know English, you can't work, uh, it will not work, right? So we have to study science, maths and English. Very much interested, if you are interested in this field, you have to study more. So then only, if you know the theories, right? So how this work, how the components work, not only this one, this is related to robotic, right? So if we learn most of the things, that will be very much helpful for us to pursue the career towards engineering, right? Engineering. And if you want to become a doctor, you have to work more on scientific things, right? So that is why we are learning these applicable things, and you have to work more on your theories and the applicable things as well, right? So consider more on the theory things, theory parts, right? So in this multimeter, how we measure is simple, right? The device is now turned off. Turned off means there is an indication shows that the device is turned off. So this is a knob, right? In this knob, we can turn clockwise or anti-clockwise, right? So we can turn it. So as the value indicates that, here it has, I can show it in the slide, right? So that way you can understand very easily. In the slide, it has the off state, right? So this is a knob. We can turn it clockwise or anti-clockwise. This is if it then this is an indicator, right? So if the indicator is in the off state, the device is in off state, right? So here we have voltage measuring things, right? So we can measure the voltages, right? This is the indication of AC current, AC voltage, right? So if we set to this area, we are going. That means we are going to measure AC voltages, right? So if we set up this area, that means we are going to measure the digital current, right? So digital current, if but also there are some values, right? So value means it has 500 volt, and it has 200 volt, it has 20 volt, and 2000 millivolts, right? So hope that we can turn the device for what we are going to measure. Right? I said that basically in robotics we will set most preferably to 20 volts, right? Because we will use within 20 volts DC, right? So we have to set for DC 20 volt, right? So in 20 volt we will measure, within 20 volt we will measure 5 voltage, 3.3 volt, 3.7, 12 voltage. We will measure those kinds of things, right? So that is why we set the knob to this one. So then after it has some indications here. It is called as ohm symbol, right? So it is a ohm symbol. We know that, and if we set the knob to this area, that means we are going to measure the resistance, right? And also uh, this symbol, this symbol is very important. So if we set the knob to this pointer, that means we are going to measure the continuity, right? Continuity means I told that this is a wire, right? So this wire is a conductor, right? That means if we apply a voltage to this wire, it will conduct the electricity, right? So what happened if the wire is broken here, right? So as an example, let's assume that the wire is cut off from here. So then the current will, if we send the voltage difference in this wire, we can't obtain the current on the other end, right? So how can we measure? How can we ensure that this is a conductor? Yes, of course, we can ensure that by testing the continuity test, right? So what we have to do is we have to turn this knob to the continuity test area, test pointer, and then we we connect this wire. So here these are the cables, right? So these are the cables we have, and we can connect these uh, wires to this device. So for basically we also be aware about the color codes, right? So we have to be aware about color codes. In normal classes they don't teach about the colors, but as an engineer I have to teach the color codes also, because this is a good engineering practice, right? So we have to connect the red color for the positive cable, right? So we have to, if we are connecting the positive wire, that means if we are going to connect, whether it is a 5 voltage or whether it is a 12 voltage, whether it is a the value, if the value has, we have to connect, go for the red cable, right? We have to connect red cables, right? If we are going to connect the ground particle, ground parts or the ground components, that way we can use black cables, or in other cases we can use blue wires, right? Blue wires also we can use for grounding the components, right? If we are connecting that to a voltage, particular voltage, we have to connect for red wire, right? So red or brown color wire we have to use, right? So in the multimeter we have three ports, right? Three ports to be connected, but we have only two cables. So what we have to understand is we only have to have two holes for measure the continuity, right? So what we have to do is we have to connect the red cable to the common, right? We have to connect the red cable to the common, right? So then after we have to connect, what we are going to measure is we are going to measure the continuity, right? So we have to connect for voltage side. So in we have two holes here. One hole is for voltage, one hole is for measuring the current, right? So then we have to connect for the voltage, right? So here likewise I have connected the device. So then after what you can understand is, if we connect these two lines here, that means the current is flowing through this one, right? So hope you hear the sound. So if I connect these two things, you hear the sound, right? So you hear the sound if we connect. So that means uh, throughout this wire there will be an electric flow, right? Electric current is flowing, right? So after we have obtained the sound, what we are going to do is we are going to test whether the wire is a conductor or not. So we are going to identify whether the conductor is good or bad, right? So what we can do is we are going to connect one line here, and then the other end we have to measure this line. So if it is continuous, the wire is continuous, there will be a sound, right? So hope you hear the sound. So there will be the wire is a good conductor, right? So that means the electricity is flowing through the wire. So that manner we can measure the defective components. That is why we learn these things, right? Because you obtain let's say you obtain uh, uh, let's say this is a motherboard of the radio, right? Example, as an example, obtain this is the motherboard of your radio, right? In your radio I told you that there might be cases that the fuse can be blown out, right? So how can we test the fuse, right? Whether it is working or whether it is defective, right? How can we measure that? By using the continuity test, right? So on the fuse and two ends we set like this, and then we measure the fuse both ends, right? Then after, if the sound is hearing, the fuse is working fine. If there is no sound is available, then that means the fuse is defected, right? So hope you understand these things. And also I have to tell you one more thing, right? So in this device, if we want to measure the voltage, we have to set it to a 20 voltage, and we also have to connect the common terminal. You can see on the slide the common terminal and the voltage terminal, right? So on the voltage terminal we have to connect these cables to this one and this one, right? And also similarly, if we want to measure the resistance of a component, right? So I told you that each and every component has its own resistance, right? Because each and every component will resist. If I touch the electricity, what will happen? The electricity will be conducted through my body, right? Through my body to the ground, right? So that means I am resisting the electricity to flow. So I am also a resistor. So I also have a resistance to restrict the flow of current, right? So that means each and every component has its own resistance property. So how can we measure? Is very simple. We obtain this device and we set up the knob to measure the ohm values. What we do is first we set up the value to maximum to minimum, right? In reverse way, right? We don't take minimum to maximum, right? We take, what we do is we take maximum value, right? Then after, what we do is simple, right? So as an example, I can measure the resistance of this needle. So it shows that it shows the value of near approximately zero, right? So that means this particular component doesn't, that means it, the component doesn't have any resistance. Do you think if I set the value to maximum and the device is showing zero value, right? So are you think that, are you thinking that it doesn't have any resistance? No, right? Because we set the maximum value, so therefore it approximated to zero, right? So if we turn this knob to another value, which means we are reducing the value, and then we measure the resistance of the needle, right? So then we measure the resistance of the needle. So that is showing that 0.1. That also that is showing that 0.1, right? So then what I do is then I further reduce it to 2K, right? So further I reduce it and then I measure it, and then it shows that that also zero point 0.1, right? So then what I do is further I reduce it to 2000. So then it shows that nearly, then further I reduce it. So then it shows the value of 0.5, right? So that means this needle has a resistance value of 0.5 ohms, right? So that is how we measure the resistance. So in the slide also I have indicated that those things you can see that. So in the slide also you can see that this is how we measure the uh, voltage, right? So we have connected the common terminal and the voltage terminal, and then what we do is so here this is the indication, right? So this is the color indication, right? So because this is the positive of terminal of the battery, this is the negative terminal of the battery, right? The battery is powering up this component, this, which means this is a load, right? So the battery is powering up this load. So then this is the 5 volt, let's say this is 5 volts, my example, right? So this is 5 voltage. So this 5 voltage line we have to connect this by using the red cable. So that is why we insert a red cable here, and then we obtain the measurements, right? So the color code is also very important, right? So then after this is ground, right? We know that this is ground, right? The ground means this is ground, this is ground, this is ground. These are all the wire is ground, right? So then we take the measurement, and then most probably it will show this value, right? So we sorry, the difference between this and this, right? So we know that this will be a 5 voltage, right? And, if the battery is 5 voltage, this will be very much similar to this one 3 voltage, right? So voltage drop will be different. So we can measure those things, right? Then after we can measure this. Similarly, we can measure the resistance also. But when we are measuring the resistance, we have to disconnect the power, right? We have to disconnect the power supply to measure the resistance of an object, right? So then only it will show the original value, right? Then after we have removed the power, we obtain two components, and then we measure the voltage, and then we connect voltage and common, right? So uh, please understand how the wires are connected in the multimeter, right? So please understand that this one is connected to voltage and common. This one is also connected to voltage and common, right? So this is how we measure, and we set the value to, you can see that we set the value to ohms, and then we measure, right? If you have a multimeter and within 5 minutes you will be a master, right? You will become a master if you have a multimeter, right? And you can simply measure the tools, right? So these are very simple things. So the next thing is measuring current, right? So measuring current is somewhat different, because uh, in order to measure the current we have to connect the common terminal and the amp terminal, right? So that is very important, you have to consider, because this is the common, right? So common terminal, and this is the current terminal. So then you have to connect. But after you have connected these two wires, we also have to connect series connection, right? We also have to connect seriously, right? Series means so what we do is we take parallel measurement, right? If we put a resistance for the multimeter, it will look like this, right? So this is the resistance, and this is the connection. This means this is a parallel connection. We learned this in earlier class, right? So in previous class we learned this thing, parallel connection. But in here we don't see any parallel connection because this is a single connection, right? Single connection, right? So in order to measure the current, we have to connect this seriously, right? So we obtain the positive terminal, and then we connect here. After that, the current will flow through the multimeter, and then the common terminal will come, and it give the current to the bulb, right? Then after, the bulb is grounded. So that this is the way we measure the current, right? This is uh, only this thing is different from the other things, right? So, and also I have another thing. This is how we measure the continuity, right? This is these three things are similar, right? These three things are similar because we connect common terminal and voltage terminal to measure the components, right? If we set the value to voltage, and then we can measure the voltage. If we set the value to resistance, we can measure the resistance. If we set the value to this one, so hope you know that this one, we can measure the continuity. So these are similar things, right? But if we want to measure the current flow, that means the current, we have to connect like this, right? I will upload the slide in our WhatsApp group. So hope you refer this and hope you understand this. Then after, you practically measure these things, right? Practically means don't measure your home appliance current, right? So practically measure means you practically measure the voltage and current in your Arduino box, right? What is inside your Arduino box? You can obtain a small LED bulb, and then you can obtain a small 9 voltage battery, or you can even get a 5 voltage battery, and then you connect the battery by using the breadboard, right? By using the breadboard, you connect the battery and the LED bulb. Then what you can do is you measure the values of the uh, voltages, currents, and resistance, etc., right? So these things you can practice. So that is all about the measuring electrical properties. Okay, so if you have any doubts, you can ask it to me. So do you have any doubts regarding this one?
No, sir.
No doubt, sir.
Yeah, then we can move on, right? So then after, we are going to learn about circuit diagrams, right? Circuit diagrams means this is a good practice if we have to transfer our circuits to other people, right? So as an example, uh, for my class, one person is designing a circuit, right? And another person is designing another circuit, right? So how can I identify that the both circuits are same or not? So that means we have to go and find about what are the circuit diagrams, right? Circuit diagrams means if one person is designing a circuit, the other person will, for the other person, it is very difficult for him to understand the first person's circuit, right? Because the wires are messy, right? If we look at this one, so if we have disconnected these things, right? If you saw this robotic car, and for the other person it is very hard to understand what it is wired up, right? So in order to understand, we have to uh, show the circuit diagrams. So then each and every person uh, can understand easily about the diagrams, and they can also work on the different things, right? So that is why we use circuit diagrams. So it is very simple and easy to understand, right? So we don't have to consider about these things, and it is very simple for you to understand, because uh, which means these are the symbols, right? We use symbols for drawing the circuit diagrams, right? So this is if we see this, we can understand this is a battery, right? Which means this is not only a battery but a series connections of a battery of batteries, right? Because we have battery, one battery here and two battery here. If there are more than one batteries are subjected, we use this line, right? So this is a positive terminal, this is a negative terminal, right? Then the wire is connected on the bulb here, and then there will be a voltage drop across the bulb, and then after another bulb is connected, and then the second bulb is grounded. So that way the electricity will flow through this way. This is how a wiring diagram is done, right? So after seeing the circuit diagram, we can wire up all the components, right? If I as an example, I am giving you the components, right? So I say that you connect whatever you want, right? So this you will be little bit confusing, right? How can we connect? What are the terminals? How can we wire? What wire do we have to connect? And how can we work on the breadboards? So these things will be confusing, right? So in order to easily identify and understand about what I'm saying, we can use circuit diagrams, right? So that is why we learn circuit diagrams, right? And also this is called how we wire up. This is called as electronics way, right? This is an electronics way, and this method is called as scientific way. Both are same things, but what is the difference between these two things? Can you identify any difference between these two things? Can you tell it to me?
In the science way, the batteries are on top. In the electronics way, the positive terminal is on top.
Yeah, yeah, that is the difference. The battery, if we set the battery on the top, that means we are wiring this. We are drawing, right? Not wiring. We are drawing this as scientific way, right? If the batteries are on the left side, that means we are wiring this, right? But also in engineering practice, we have to consider one more thing, right? What is, so this is the actual diagram, right? This is a circuit diagram, I call it. This is a schematic diagram, right? I will call this as a schematic diagram. This is an actual diagram. So this is how a battery and the switch and the other components, right? Other components will look like. So I say that there is a wrong in this picture, right? I say that this picture is engineeringly, in engineering term, this drawing is poor. So can you identify what is wrong in this picture and tell it to me? Because I can identify that. You might say that, of course, you will say that the positive terminal should be connected to the switch. Then after the switch, it should be connected to the positive terminal of the bulb, and the negative terminal should be grounded, right? That is okay. So what is wrong in this diagram? If I put the switch on this way, which means I have a battery here, right? I have the positive terminal, and then I insert a bulb. And then after I put the switch here, right? Then after I wire up to the ground. This is very wrong. Huh? This is very much wrong, because the positive terminal is connected to the bulb, directly to the bulb. Then after it is grounded. Then after it is connected to the switch, right? So this is very wrong, because if the current is flowing very much higher, the bulb will be defected, right? The bulb will be damaged. So that is a very good practice. We have to put a switch on near to the battery, right? Directly to the battery. We have to directly connect the positive terminal to the switch, right? So that is very important. We have to consider, right? Then after the switch, we can connect another terminals, right? Another terminal to the positive terminal of the bulb and negative terminal to the ground. This is correct, right? This is correct. This is how we connect, right? But the thing is, the problem is color coding is the problem, because he used a green color wire to wire the positive terminals, right? This is wrong. What we have to use is, we have to use a red color line, right? We have to connect a red color wire, and then we have to connect this switch, and then after the switch is turned on, then after it is also a positive terminal, right? So we have to also connect the red color wire. Then after, we have to select a blue cable, and we have to ground these things. So after you have connected these things, if someone is seeing your diagram, he can easily identify what are the wires are showing that, right? So that is an engineering practice. We have to show the color codes, right? So that way, if another person comes and see your uh, see your work, he can easily identify that this is the cable, and this is a positive terminal, and you have connected the negative terminal. So on all the other, if we have also another motor here, right? Another motor here, and then that also can be wired up by using the blue wire should be grounded, and then we obtain a red color wire, and then we can connect these two wires. So this is how we draw the diagrams, right? So hope you understand these things. If you have any doubts, you can ask it to me. Right. Next thing, basically I prefer to use this way, right? This way is also correct, this is also correct, this is also correct, right? So this is actual diagram, these are schematic diagrams. I prefer to use these diagrams. So I will, if it is if I'm giving you some of the exercises for you to practice, I will prefer to give you these diagrams, right? In exercises, I will give you this diagram, so that you can understand the circuit, and you have to uh, actually actually connect the circuits, right? Why I'm doing like this is, there is a reason behind this, because from your grade 6 to up to in universities, we will learn these things, right? We will learn these things. So if you know and understand these things and make it real, that means you can create an actual circuit. That is enough, right? Because you understand these things and you can apply it to another things, right? So that is why I'm working with these circuits, right? This way, electronics way, right? So then I have an exercise for you. I have two exercises for you, right? So after this exercise, you can practice in your home and then show it to me, right? Uh, this is an exercise. Draw the schematic diagram for the following figure, right? You have to draw a schematic diagram. I will upload the slide in our WhatsApp group, and you can see the picture, and you can draw the diagram. Okay, so that will be very easy. These are very simple and easy question, right? If you understand the thing, you can easily draw, right? But you have to be aware about the color codes, right? And also the diagrams can be drawn in your paper, right? In your paper or in your exercise book, and you have to take a photograph of your answer, and then you can upload it to the WhatsApp group. to me, or personally you can message it to me, right? And also there is another way. uh, the second way you can answer these questions. Basically my students were prefer to use this method because nowadays all the things are computerized, right? So what you can do is you use your computer to design the circuit, right? As I showed in the lecture previous slide. You can design this one in your computer, and then you send it to me, right? Even you can use paint to draw the circuit and send it to me, right? But you have to be aware about the color codes, right? Even further that there is also another way, right? Another way means there you can submit by using a software called fritzing, right? I will type here. The software is named as fritzing, right? Fritzing, there is a software for us to practice those things, right? We can practice some of the components. There are some components, right? As I showed here, there are some Arduino and the relay components. These actual components are readily available in the software, right? So you can virtually work on the software and you can navigate on the components, right? So that way we can use the fritzing software also in upcoming classes. We can I will also teach you how to work on those softwares also, right? And also best best software is I will show it in the next lecture. There is an online platform for us to deal with the electronic components in a real manner, right? So that will also be discussed in our next lecture. So before we go to that one, we will complete the exercise, right? So this is what you have to do. Draw the schematic diagram for the following figure. You can see this figure. This is a battery and it has a switch inside here. And then you can see that how they wired up, right? So here they have wired the breadboard in here, and then they obtained the wire from this one to this one, and they inserted the LED bulb. Then after they inserted this one, right? So this is how they wired up is totally wrong because the color code is wrong, right? So uh, so you have to consider the color code and you have to redraw it according to the schematic diagram, right? So hope you understand that one also. And then after the exercise 2 will be this one, right? This is a schematic diagram, right? How will you connect the circuit diagram by using a breadboard, right? You have to show it to me. Even if you have the components with you, that means if you have an IC, 5-volt battery and 470 ohm resistor and the LED bulb, you can you can create an actual circuit. Okay, you can create an actual circuit and show it to me. You can take a photograph and then show it to me. Okay, most of the students are using actual components, right? So they buy these kinds of components and then they actually connect the circuits and then they show it. Then they take a photograph and then they show it to me, right? That is most of my students do. But uh, if any person, any student is suffering to buy those components financially, what they do is they work on the virtual environments, right? Virtual platforms that I told you earlier. They use fritzing software and then they design, they show these diagrams. After they show, after they see these things, and then they work on the virtual platform, and then they take a screenshot of their image and then they show it to me, right? So that is how my uh, another students did in previous classes, right? So hope you can also work on these things. If you practice these things, that will give you more benefit from this class, right? So the practice is very important. You can also participate without practice, right? That's no matter. I will not going to compromise you in each and every thing, right? So if you are interested, you can work on the application things, right? If you can't afford it to that one, you can just sit on the class and you can watch the lectures and you can ask questions. And if you don't know understand anything, that you can ask it to me, right? Then also in future I will show some videos also for you to understand more, even more things, right? So that is how I explain it to my students, right? So if you have any doubts, you can ask it to me and clarify it, up to now what we have done so far. It is the time for you to ask questions, right? It is your
No
time.
doubt.
You can ask questions. So as a recap, what we have done so far is simple, right? Today's lecture, we understood about what is breadboard and how the wires are connected inside it, right? After that, how can we connect the breadboard? It is very simple, right? We connect battery to the breadboard and then we obtain voltage from this one and then we connect this one. So basically why we use breadboard is simple, right? Uh, if we want to join these wires together, what will you do? If you want these two wires to be joined, right? So what will you do? You will manually take these wires and join, right? This way you will join. This is not the best practice, because if you touch this and it will affect, it will not going to affect because it's a small current. But what will you do is simple, right? We just take jumper wires and then we connect it to a breadboard and then we supply the voltages along with the components, right? So that is why we use circuit boards in order to connect two wires or two components, right? So hope that is easy. And there are dot boards, line boards, and printed circuit boards available in the market for us to deal with those things, right? Then after we learned types of wires, jumper wire, and there are male to male, female to female, male to female wires available. Auto wires, these wires will be using for 12 voltage uh, DC currents and more. For if the voltage is very high, we will go and use these auto wires, right, rather than using jumper wires. Then we identified the measuring device and how we can measure the voltage and how we can measure the resistance, and also we learned about how we can measure the current flow, right? Current, and also we learned how we can measure the continuity test, right? So these things will be very easy. Circuit diagrams. These are the circuit diagrams, and we learn for the schematic diagram, right? So basically, what I have planned is simple, right? Basically, I plan to complete the lecture within 1 month, but you students are currently studying at grade 7, grade 8, so those students. So I'm planning to uh, conduct the class for 2 months, right? So that way you can understand more. I can even clarify more things, right? So if you can afford it to that one, please let me know in the WhatsApp group. And I have basically I have more slides to complete, right? So basically I plan to start Arduino today, but as you have indicated that the class is going speedily, so I have slowed down my speed for you to understand these things, right? So hope the class will be 2 months. No worries, you can learn more things and we can communicate each other, right? So that way we can learn more things. Do you have any doubts? or shall we wind up?
Not answer.
Okay, thank you for attending the class. Have a good day.
Thank you, sir. Goodbye, sir.
Yeah.
Thank you, sir.
Thank you, sir.
Yeah.